Hi everyone, this is the 28th lecture of Engineering Economy. So let's solve problem 7-54. An apartment building in your neighborhood is for sale for $140,000. The building has 4 units which are rented at $500 per month each. The tenants have long-term leases that expire in 5 years. Maintenance, other expenses for care and upkeep are $8,000 annually. A new university is being built in, let me double check it. I'm not sure, there's some typos in the problem description. Sorry about this. So we are solving 5-54. Okay, so let me reread the problem description. An apartment building in your neighborhood is for sale for $140,000. The building has 4 units which are rented at $500 per month each. The tenants have long-term lease that expires in 5 years. Maintenance and other expenses for care and upkeep are $8,000 annually. A new university is being built in the vicinity, and so here vicinity, and it is expected that the building could be sold for $160,000 after 5 years. Then we are required to answer these 2 questions. What is the internal rate of return for this investment? And should this investment be accepted if the other options have a rate of return of 12%? Okay. So this is the problem number 7-54. So the total annual revenues are $24,000. Why is that? A monthly apartment rent is $500 per month each and per unit, right? And there are 12 months in a year, and there are 4 units in an apartment building. So $500 times 12 months times 4 units will be $24,000. Okay, so this is gonna be the total annual revenue. Now let's draw the cash flow diagram. So an apartment building is for sale for $140,000, right? And the lease expires in 5 years. So 1, 2, 3, 4, and 5. And the annual revenue is, the annual revenue is $24,000. Okay. And it is expected that the building could be sold for $160,000 after 5 years. Okay. And what else? The maintenance expenses is $8,000 annually. Okay, so we need to consider maintenance cost of $8,000 annually. Okay, so this is the cash flow diagram that we need to consider. To find the internal rate of return, the net present worth must be 0, right? Which is negative $140,000 minus 8,000, and you need to convert it to equivalent present worth. So you need to multiply by P given A, I over 5 period. And you need to consider annual revenues of $24,000. Again, you need to convert this to equivalent present worth. So you need to multiply by P given A, I over 5 period. And also the future sum of money, which is $160,000, need to be considered. You need to convert it to the equivalent present sum. So P given F, I over 5 period. Is that right? Now, if you use 12% of interest rate, you will see that net present worth becomes $8,464. And if you use 15% of interest rate, then net present worth, which is this value, will be negative $6,816. Okay. So what you need to do is use linear interpolation. Then you will end up with I would be 13.7%. Okay, and which must be somewhere between these two interest rates, right? 12% and 15%. So this is the answer for part A. And how do you answer part B? Should this investment be accepted if the other options have a rate of return of 12%? So how do you answer this question? At 13.7%, which is from our calculation, at 13.7%, the apartment building is more attractive than the other options, right? So it should be, the investment should be accepted. Okay. Then Next problem that we are going to solve is problem 7-55. A new machine can be purchased today at $300,000. The annual revenue from the machine is calculated to be $67,000, and the equipment will last 10 years. Expect the maintenance and operating costs to be $3,000 a year and to increase $600 per year. The service value of the machine will be $20,000. What is the rate of return for this machine? Okay, so let's draw the cash flow diagram first. We are working on problem 7-55. So the new machine can be purchased today at $300,000. And the maintenance and operating costs are $3,000 for the first year, and then increased by $6,000 per year. So at the end of first year, the maintenance cost is $3,000. And then increased by $6,000. I'm sorry, and then increased by $600 per year. So at the end of second year, it's going to be $3,600. At the end of next year, it's going to be $4,200, and so on. Okay? And at the end of 10th year, we have a certain amount, right? 1, 2, 3, up to 10. And what else we need to consider? Okay, the annual revenue from the machine is to be $67,000. So we need to consider uniform annual series of $67,000 for the next 10 years. 67,000. And there is a service value which is $20,000 at the end of 10th year. Okay? And here, the annual maintenance and operating cost can be broken into two cash flows. Here, annual maintenance cost can be broken into two components. One for the uniform annual series, of $3,000, plus arithmetic gradient series, right? So 0, 1, 2, 3, 10. You have 600, 1200, and so on, right? So in that case, G would be 600. Here, A is 3,000. Okay? So here, to find internal rate of return, net present worth must be 0, right? Again, net present worth is the present worth of benefit minus present worth of cost. Okay? So here we have $67,000, but it must be converted to the equivalent present worth. So you need to multiply by P given A, I % over 10 period. Again, you need to consider $20,000 of service value, which must be converted to the equivalent present worth. So 20,000 times P given F, I over 10 period. And here, the negative cash flow, which is 300,000, and minus $3,000 times P given A, I over 10 period, minus this arithmetic gradient series of 600 times P given G, I over 10 period, right? So if you compute this, it must be equal to 0, right? So if we try I equals 10%, then you will see that net present worth would be $87,255, which is a lot larger than 0. Okay? If we use 18% of interest rate, then net present worth is negative $17,173, which is less than 0. So let's try one more interest rate, somewhere between 10 and 18. So let's try 15% of interest rate. In that case, net present worth is $9,130, which is greater than 0. So we know that the desired rate of return value should be somewhere between 15% and 18%. Okay? So the next step is using the linear interpolation. You can find the more accurate value of rate of return, which should be 16%. Okay? So please double check with this value at home. Okay? So this is the problem 7-55. Okay, next problem is problem 7-58. An investor purchased 100 shares of Omega common stock for $9,000. He held the stock for 9 years. For the first 4 years, he received annual end-of-year dividends of $800. For the next 4 years, he received annual dividends of $400. He received no dividends for the 9th year. At the end of the 9th year, he sold his stock for $6,000. What rate of return did he receive on his investment? Okay, so let's visualize our situation. So he purchased the stock for $9,000. Okay. And 1, 2, 3, 4. So for the first 4 years, he received annual end-of-year dividends of $800. And then for the next 4 years, he received annual dividends of $400. Okay. And at the end of the 9th year, he sold his stock for $6,000. Okay, that's it, right? So again, to find the internal rate of return, the net present worth should be 0. Okay, net present worth can be calculated by present worth of benefit minus present worth of cost, right? So how do you calculate the present worth of benefit? The easiest way is $400, which is starting from the first year through the 8th year. So the $400 for the next 8 years plus the rest $400 for the first 4 years plus $6,000 at the end of the 9th year. Okay. So here we're going to get $400, but it should be converted to the equivalent present worth. So you need to multiply by P given A, I over A period. Then what is left over? Another $400, right, for the first 4 years. So again, you need to convert it to the equivalent present sum. And then finally, you need to consider $6,000 at the end of period 9, which will be converted, is P given F, to equivalent present sum of money. So you need to multiply this factor, right? And present worth of cost is simply 9,000. Okay. So here we know that 400 P given A I over A period plus 400 P given A I over 4 period plus 6,000 P given F I over 9 period equals, is equals 9,000. Okay. So we're going to use trial and error method. If I is 3%, then the left-hand side becomes $8,893, okay, which is smaller than 9,000. If I equals 2.5%, the left-hand side of this equation becomes $9,177, which is greater than $9,000. So we know that the desired rate of return value should be somewhere between 2.5% and 3%. So next step is to use linear interpolation. Okay. Then the rate of return value should be 2.81%. Okay. Again, I want you to double check this value. Okay. So this is the problem 7-58. Okay, and next problem is 7-59. One aspect of obtaining a college education is the prospect of improved future earnings in comparison to non-college graduates. Sharon estimates that a college education has a $28,000 equivalent cost at graduation. She believes the benefits of her education will occur throughout 40 years of employment. She thinks that during the first 10 years out of college, her income will be higher than that of a non-college graduate by $3,000 per year. During the subsequent 10 years, she projects an annual income that is $6,000 per year higher. During the last 20 years of employment, she estimates an annual salary that is $12,000 above the level of the non-college graduates. If her estimates are correct, what rate of return will she receive as a result of her investment in a college education? Okay, so as usual, let's draw the cash flow diagram first. So we are working on problem 7-59. Okay. So she estimates a college education has a $28,000 equivalent cost at graduation. So she estimates $28,000. And 1, 2 through 10. And she believes the benefit of her education will occur throughout 40 years of employment. So we're going to consider 40 years. Okay? And she thinks that during the first 10 years out of college, her income will be higher than that of non-college graduate by $3,000 per year. So there is a uniform series of $3,000 for the first 10 years out of college. And her income will be higher than that of a non-college graduate. $6,000 per year higher during the subsequent 10 years, right? So from 11, 12 through, let's say, 20. She projects an annual income which will be $6,000 per year higher, okay? And so these are first 10 years, and during the subsequent 10 years, right? So how many years left over? Starting from 21 through 40, we have 20 years, right? Okay. And according to the problem description, during the last 20 years of employment, she estimates an annual salary that is $12,000 above the level of the non-college graduate. So here we have $12,000. Okay. Okay, so that's it, right? So to find the internal rate of return, again, we are going to use net present worth, which can be computed by present worth of benefit minus present worth of cost equal to 0, okay? So here how do you get the net present worth? Okay. So how do you compute present worth of benefit? Present worth benefit would be $3,000, but you need to convert it to equivalent present sum of money. So you need to multiply by P given A, I over 10% plus this $6,000 should be converted to the equivalent present sum, right? So it's going to be P given A, I over 10 periods. Again, you need to convert it to the present sum of money over 10 periods, 10 years. Likewise, this $12,000 will be converted to the equivalent present sum at the end of period 20, and then again it will be converted to the equivalent present sum of money at the end of period 0. So 12,000 times P given A, I over 10 periods, no, I over 20 periods, and then again multiply by P given F, I over 20 periods. Okay? Present worth of cost is 20,000. Okay? So again, we are going to use trial and error method. If you use 12% of interest rate, then the present worth of benefit will be 37,160. Okay? Which is larger than present worth of cost. Okay? If you use 15% of interest rate, present worth of benefit will be $27,090, which is less than $28,000. So you know that the desired rate of return value should be somewhere between 12% and 15%. So what you need to do is using the linear interpolation. You can find the rate of return of 14.73%. Okay? So that's going to be the answer. Okay. And next problem that we are going to solve is 7-69, which is about incremental analysis. And, you know, in chapter 7, I just briefly mentioned about the incremental analysis, which is very useful technique when there are two or more alternatives. And this screen just shows the formal procedure for the incremental analysis. And the cash flow of the incremental analysis, incremental investment, is computed by taking the higher initial cost alternative minus the lower initial cost alternatives if the incremental rate of return is greater than or equal to the minimum attractive rate of return, which is the same value of I used for present worth analysis and the annual cash flow analysis earlier. Okay? If this is true, then we choose the higher cost alternatives. If the incremental rate of return is lower than the minimum attractive rate of return, then we need to choose the lower cost alternatives. And also, if you consider the increments of borrowing some money, however, if the incremental rate of return is less than or equal to the minimum attractive rate of return, we accept the increments. Okay? So using this concept, we are going to solve the problem number 7-69. Okay? Okay, so two alternatives given in this table. If 5% is considered the minimum attractive rate of return, what alternative should be selected? So, okay, first let me write down the problem number 7-69. As the first step for the incremental rate of return analysis, we need to compute the cash flow of the incremental investment by taking the higher initial cost alternative, which is alternative B, minus the lower initial cost alternative, which is alternative A. Okay, so we have 0, 1, 2, 3, A, B's, negative 2,800 each, negative 2,800, 1,100, right? So we will make another column represents B minus A. Okay, which will be negative 800, 300 each. Okay, and our criterion would be if incremental rate of return is greater than equal to the minimum attractive rate of return value, then choose higher cost alternative. Choose plan B. Okay. So when you're looking at the increments of investment, we accept the increment if this is true. Okay. Of course, if incremental rate of return is lower than the minimum attractive rate of return, then we're going to choose the lower cost alternative, which is alternative A. Okay. So, based on this, we can draw the cash flow diagram, which is negative cost of 800 at the end of period 0, and then at the end of period 1, 2, and 3, there's a positive cash flows of $300. Okay. So now we compute the incremental rate of return based on B minus A, right? So that's going to be net present worth equals 0. So 800 equals 300, and P given A, I over 3 periods, right? So in this case, P given A, I over 3 periods equal to 800 divided by 300. How much is this? It's 2.6667. Okay. And so if you look at the compound interest table, if I equal to 6%, P given A over 3 periods is 2.673, which is very close to this value. Okay. And what about 7%? If I equals 7%, P given A over 3 periods is 2.624. 624. Okay. So obviously, the rate of return value should be somewhere between 6% and 7%. But it will be a lot closer to 6%. Okay. So if you use linear interpolation, you will see that the rate of return value should be 6.1%. Okay. So which means that the incremental rate of return value would be 6.1%. Okay? Because the rate of return on the increment based on B minus A exceeds the 5%, which is considered as the minimum attractive rate of return. Your decision should be choose alternative B. So choose the higher cost alternative, which is alternative B. Okay? Okay, so this is the problem 7-69. Okay? Okay, the next problem that we are going to solve is problem 7-70. Again, the problem 7-70 can be easily answered if the incremental analysis is used. Okay? So consider two mutually exclusive alternatives. If the minimum attractive rate of return is 10%, which alternative should be selected. So we are working on problem 7-70. Okay. So let me redraw the cash flow table. 0, 1, 2, 3, 4. X and Y. Negative 100, negative 50. 35 each. And 16.5 each for alternative Y. Okay. So at first, we need to compute the cash flow of the incremental investment by taking the higher initial cost alternative, which is alternative X, right? Minus the lower initial cost alternative, which is Y. Okay? So we have negative 50. Negative 100 minus negative 50 becomes negative 50. 35 minus 16.8, I'm sorry, 16.5. It's going to be 18.5, right? So we have 18.5 each. Okay. So if you draw the cash flow diagram, for this, we have initial cost of $50, and for the following 4 years, there is an annual benefit of $18.50. Okay. Now we need to compute the incremental rate of return based on X minus Y. Okay. So we have again, we are going to use this criterion. So 50 equals 18.5 times P given A, I percent over 4 periods, right? So P given A, I over 4 periods equal to 50 divided by 18.5, which is 2.7027. Okay. So by interpolating, you will see that incremental rate of return value should be 17.8%. Okay. And this value should be compared to the minimum attractive rate of return, which is 10%. Okay. And because the rate of return on the increment based on X minus Y is greater than the minimum attractive rate of return, which is 10%. what is your decision? The increment is desirable. And so the higher cost alternative, which has X, should be selected. Okay? Okay, so this is the problem 7-70. Next problem that we are going to solve is 7-74. The contractor is considering whether to buy or lease a new machine for his layout site work. Buying a new machine will cost $12,000 with a service value of $1,200 at the end of the machine's useful life of 8 years. On the other hand, leasing requires an annual lease payment of $3,000. Assuming that the minimum attractive rate of return is 15%, and on the basis of an internal rate of return analysis, which alternative should the contractor be advised to accept? The cash flow diagram is given like this. Okay? So we are working on problem 7-74. Okay? So first, we need to compute the cash flow of the incremental investment by taking the higher initial cost alternative, which is alternative A, right? Minus lower initial cost alternative, which is alternative B. So we need to add one more column for A minus B. So that's going to be negative 9,000 at the end of year 0, right? Unless otherwise, it's going to be 3,000. And at the end of period 8, it's going to be 1,200. Okay? So there is year 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay? Now we need to compute the incremental rate of return based on A minus B, like this. Okay? If you draw the cash flow diagram, it's going to be initial cost of $9,000. And for the next 7 period, one, 2, 3, 4, 5, 6, 7. There is an annual benefit of $3,000. Also, at the end of period 8, there is benefit of $1,200. Okay? Now we need to compute incremental rate of return based on A minus B, right? Again, we are going to use the criterion net present worth equal to 0. So here 9,000 equals 3,000 times P given A I over 7 periods plus 1,200 times P given F I over 8, right? So again, we are going to use trial and error method. If we use 25% of interest rate, the right hand side becomes $684.36, which is a lot smaller than $9,000. Hold on seconds. I think this is wrong. If I use 25% of interest rate, then this equation, let's say A, okay? The equation A becomes 9,000 minus 3,000, 3.161, because this table value is 3.161, minus 1,200 times 0.1678. So this value becomes negative $684.36. Okay. If you use 30% interest rate, then this equation A becomes 9,000 minus 3,000 times 2.802 minus 1,200 times 0.1226, which becomes $446.88. Okay. Now, you know that the incremental rate of return value should be somewhere between 25% and 30%. So next step is to use linear interpolation. Okay? Then you will see that incremental rate of return value should be 28%. And this value should be compared to the given minimum attractive rate of return of 15%, which is a lot larger than minimum attractive rate of return. So what is your decision? Choose the alternative A. Okay, so the contractor should choose alternative A in this case. Okay, so that is problem 7-74. And let's solve one more problem. which is 7-84. Okay, so Jean has decided it is time to buy a new battery for her car. And she has two choices, one for the Zeppo and another for Kiko. And she believes the batteries can be expected to last only for the guaranteed period. She does not want to invest extra money in a battery unless she can expect a 50% rate of return. If she plans to keep her present car another 2 years, which battery should she buy? Okay, so we are solving problem 7-84. So our analysis is based on a 24-month analysis period and an identical replacement. That is, a replacement of battery Zeppo is identical to the present battery Zeppo, right? So as the first step, we need to compute the cash flow of the incremental investment. Again, by taking the higher initial cost alternative, which is Kiko, minus the lower initial cost alternative, which is Zeppo. Okay. So the first cost should be 90 minus 56. Let me rebuild up the table. Okay, sorry. So we are having problem 7-84, and there's a year 0, Zeppo and Kiko, and here we have Kiko minus Zeppo, right? So this is the negative 56 and negative 90, right? So Kiko minus Zeppo would be negative 34. And at the end of year 1, you need to purchase another Zeppo. So you need to spend another $56. But at the end of year 1, you don't need to do anything for Kiko, right? Because its useful life is 2 years. So there is no cost required at the end of period 1. So Kiko minus Zeppo at the end of period 1 would be 56, right? And at the end of period 2, both alternatives requires $0. So it's going to be 0. Okay? So based on this, you can draw the cash flow diagram. There's an initial cost of $34, and then the period 1, there is a benefit of $56, and then the period 0, period 2, there is no cash flows, right? And again, we are using the net present worth equals 0 criterion. So simply 34 equals 56 P given F I over 1 period, right? So P given F I over 1 period equals 34 divided by 56. How much is this? That is 0.6071. Okay? So if you look at the interest table from our text, P given F over 1 period if I equals 60%, no, sorry, if I equals 50%, I equals 50%, P given F over 1 period is 0.6667, which is larger than 0.6071. Okay? So you need to look at higher interest rate, which is 60%. Then P given F 60% over 1 period would be 0.6250, which is still larger than 0.6071. Okay? So obviously, you will see that the incremental rate of return value should be greater than 60%. Okay? And this value should be compared to the 50%, which is considered as the minimum attractive rate of return. So incremental rate of return is greater than the minimum attractive rate of return, which is 50%. Okay? So what is your conclusion? So we need to choose the higher cost alternative, which is alternative Kiko. Okay? So choose Kiko. That is the answer for problem 7-84. Okay. Okay, so this is all for today. Okay, thank you very much. Bye-bye.